Hello, Michael here with another Renderman 23 tutorial. Today we're going to be having a look at how to do Open VDB rendering with Renderman 23. So to start off, the first thing you need to do is make sure that the Open VDB plugin is active. It does come, the Open VDB read does come with your Renderman distribution. So make sure you just go to Windows, Settings, Preferences, Plugin Manager, and mine's all the way down the bottom, Open VDB. Just make sure that is loaded so we can actually read the VDB assets that we're going to import. The next thing you want to do is go up to your shelf, and we've got a couple of things here. These are your materials as well as your volumes. We're going to create an Open VDB visualizer. When you create that, you'll see it there. It doesn't look like anything in the viewport at the moment, but if we have a look in the Hypershade editor, you will see that it has created a Pixar volume as well, and this is actually the shader for our Open VDB, and you'll see that under your materials right there as well. So to read it, we'll just select our Open VDB Visualize, and we need to open a file. I've got one prepared already, so just navigate to your file, and I'm going to use this. Open VDBs can't be created by default in Maya and then sort of re-imported. If you wanted to do it that way using like Maya Fluids, you'd have to use a third-party plugin to achieve that. I think the only one that does it at the moment is Besh's VDB, but that does cost money, so just bear that in mind. If you're wanting to get the access to the clouds that I'm going to use in this one, this cloud, and two others that I'm going to distribute, they will be available to patrons this week at the $5 tier. Otherwise, you can get some other examples of Open VDBs on the Open VDB website. I'll put a link to that in the description as well. So with the visualizer, we can go to the visualize shape, and then we've got a couple options here. The first thing, the VDB grid name, a star just means it's going to use all. Density means it will just show you the grid for density. With this one I only have density, but some other ones that you may see would be velocity and fuel. The other thing that we can adjust is the way that it's actually visualized. So at the moment we've just got these sort of voxely leaf node type things. We can disable those, and we can click active voxel, which will give you a better rendition of what the cloud sort of will actually look like. This may slow down certain people's systems depending on what your CPU is like, but I prefer to work in this sort of mode. If you have a VDB sequence, for example this one, I will change this back to leaf nodes because it's a bit heavy. You can play through that, and actually it's going to be quite difficult to see because they probably don't, there's not a lot of animation in this, it's quite subtle, but if I go back to active voxels and just skip between a couple of frames, you can see that there is actually a little bit of animation there. Renderman in the Open VDB read will automatically look for sequences within that file path, or if they're all in the same file and they're numbered accordingly like this, then you will be able to access them as an animation. But I'm just going to go back to the Stratocumulus that I was using before. The next thing we do is put in a light. You can use any old light here, and sometimes it's good to use a HDR on a dome light, so we're going to do that as well. Alright, so I've just set up this shot, so I'm cropping out all the buildings and stuff that are in this just so I can get the sky, and it can contribute a little bit of lighting to our cloud. Now, if for some reason you run a render and it looks like this, that's because we need to change a couple of things in the Hypershade editor for this, for the volume. So we'll go into the Hypershade editor and we'll select our volume. And what's happened here is the density float primitive variable doesn't know what to look for, so we need to type in density in this case, and it's just going to look for the density parameters in our VDB that it's reading, and then it will be able to determine what's dense about this VDB and how to apply light, etc. to it. So as I said previously, each VDB that you read will have information like velocity and temperature, and in this case density, which will make up how it's read and interpreted by Maya, and in this case Renderman. So start off with the cloud doesn't look too bad. It's a little bit cottony looking to me. So what we'll do is we'll actually set it to the set it to Pixar's recommended cloud settings, which I've created a preset for. Before you adjust anything, a good thing to do is just save a preset of your default, like I also have here. You just do so by doing that and just change its name to default, which you can see. And then I'm just going to replace the default with the Pixar version of this. And the main thing that's changing is the diffuse color, which it's setting to 50% gray, and the anisotropy, which is set to these values here, which you can copy if you wish. And we can just run an IPR again and just make sure that's in the attribute editor, so we can just edit it here while the IPR is running. Now you'll see the cloud is a lot darker. That's due to the way the anisotropy has been handled, and as well as the diffuse color. So if you wanted to increase the value of the cloud back to something a little bit more like this, if you wish, we can actually just increase the diffuse color for starters. They sort of recommend a 50% gray, which in my experience isn't too far off looking good. It really just depends on what you want your cloud to look like. They should be transmitting light because they are essentially just water. They should also be trapping a lot of light, which would be giving you the dark undersides that you'd see in sort of storm clouds and that sort of thing, which is probably a little bit closer to what we've got going on here. Consider also putting more lights in and light linking them to your cloud, because the cloud's the only thing I've got in this scene. It doesn't really matter for me in this case. Something I'm also going to change is if I just go to my render settings, I'm just going to quickly add in a denoise node for that, so when I'm rendering I can just get a hint at what the denoise will look like. Clouds and volumes by default are very noisy. It's very difficult to render them because they're made up of lots of little points. So when we hit N here now in the IPR, we can just sort of see what a denoise version will look like. Denoising clouds is also very difficult for Renderman or any renderer because of them being noisy just by virtue of being a bunch of points. So when you denoise them, you might get some weird artifacting that sort of looks a little bit like paintbrushy effects rather than cloud. So just bear that in mind. You may need to render this to a high sample rate to get an accurate representation of your cloud. This will all depend on how close the camera is to the cloud, obviously, and the resolution of your VDB. So that's rendered up to approximately 128 samples, and at 1:1, this is only 540p, I think. It's not too bad. The denoiser, even better. But if you're using this in a scene, what you would want to do is just render out a single frame of your cloud, unless it's animating, and have it composited in after the fact. So you don't have to render it every single frame and take up all your rendering time just rendering a cloud that you could just render once, because it's going to be in the background unless it's a focal point, and it's non-interactive. Even if it's actually a focal point, if it's non-interactive, it's not animating, just render it once, composite it after the fact. And we can go through that in a tutorial in the future if you wish, if you're wanting to know how I would handle doing something like that. So further to visualizing this cloud, I would probably just chuck in hello to the people that created this image. We can just create another light by duplicating that one, and I'm just going to bring it in over the top so we can see a little bit more of the silhouette, just a bit more contrast, and I'll move that around to the back a little bit there as well. Alright, so that's giving me a little bit more of what I want to see compared to the last one, which is a bit dull. Getting a little bit of a sort of highlight there. This is overall still a little bit dark for my taste, so we're going to try and recapture a bit more of the lightness that we saw from this one, but we still want to see the translucency that we sort of are experiencing here in this side of the cloud. So we're going to grab our volume. Okay, so if I lower the low bend factor, that's going to start to lighten the cloud a little bit, but overall make it a little bit more opaque, so it's actually going to be bending the light sort of back toward the camera more than this one is, where it's sort of been captured and scattered within the cloud and then not bounced back. So if you're just looking to bring back the overall opacity of the cloud, you could do that. And then the primary anisotropy, the closer you get to a value of 0, the more it's going to be isotropic, so it's not going to be reflecting light in random sort of directions. So that will sort of increase its value overall as well. So further we get into the negatives, you can see it's scattering inside the cloud and not back to the camera. Whereas we do more of this, we can get more of a lighter appearance in our cloud. So if we compare that to that, that's sort of getting to where it's more what I want to see. So a nice grayer top on the non-lit side versus this one where it's completely dark. And then again, you could still just add more lights. Obviously, the more lights you add, the more difficult it is for Renderman to deal with. More lights equals more rendering, more rays. However, it's not too bad like this with just the 2 lights. And as I said before, compositing is your friend in this case. Now, multiple scattering. This option will essentially, at the moment, it's single scattering, so it's not actually calculating the light being bounced around. It's sort of just simulating it through anisotropy. What we can do is, if we turn on multiple scattering, it will start to simulate that a bit more, which will sort of, in this case, give you a little bit more detail, rendering these up to about the same amount. If we just keep the denoise on, we can sort of see a little bit more detail in these cloud areas here. But that is going to increase your render time as well. So figure out whether it's worth it. Is the cloud a focal point? If it is, then maybe. If it's not, people aren't really going to care so much if it looks like this rather than this. So I would probably turn multiple scattering off. The only other thing is light source. You'd be using this if this was an explosion. And the light source will, obviously, if it was, or explosion, not an explosion, like any VDB that's a light source like fire or anything like that. So if we turn that on, this isn't going to be super obvious without something to transmit light onto. So we'll just chuck a cube in there, and then we just need to emit a color. And as you can see, it's lighting itself as well as lighting up the cube now. However, if you are rendering a flame or something like that and it is a light source, consider just doing the viz dev so the flame it only appears to be lighting the scene. So I'd render out, say, the flame maybe on unless you're going for a super simulation, render out the flame in a separate render layer or a separate project or whatever, and then just add in a flickering light source, a point light, or even just an area light. You're going to get a lot quicker render times that way, and your computer won't melt because even just rendering this cloud, to be fair, is quite high detail to use as a light source, but as you do that, it's going to be, having a bit of a seizure. Now, if the cloud isn't a light source, you can still use the emit color slider, and this will just light itself. Essentially, it's like adding a screen of whatever your color is. Obviously, the color doesn't have to be a grayscale color. It could be any color. The same for your diffuse color, actually, or your density color for that matter. You wouldn't really change your density color though for this sort of simulation, unless you wanted the shadows to be a non 0 to 1, non-black or white color like that. But that'll sort of depend on what sort of cloud you want. If it's a toxic cloud, then yeah, obviously go for your life, and then you can have your emit color having sort of a darker green, and then your diffuse color, you could use a more highlighted green, and then we get something that looks like that. Something that Captain Planet would absolutely hate, and that might be perfect for you. So yeah, you can fiddle around with these a lot more. Obviously, this is just how to read your VDBs, and there's a lot of different situations in which you would be using a VDB created usually in another DCC like Houdini. This one was created in Houdini by me. So yeah, That's it for this tutorial. If you found it useful, make sure you leave a like so other people can find it. And if you haven't already, make sure you subscribe, as we're bringing out CG and illustration tutorials every week, just like this one. Become a patron and access tutorial assets, bonus content, a private Discord, and more by clicking the link below.